Hello everyone, my name is Mark Shipman, founder of Quante Carlo, an AI acceleration company, and this is a product demo for Promptimizer, a prompt optimization studio. So first, let me begin by explaining what prompt optimization is at a high level. So we could say there's three kinds. The manual kind, a human provides a prompt, there's an answer from a language model, the user evaluates the quality of that answer using some method and using some technique, like just thinking about it, the user comes up with a better prompt. In the AI version of this cycle, the user provides a prompt, the language model comes up with an answer, but the language model also has other agents that it will evaluate the answer and then other techniques for coming up with a better prompt. In this version, there might be multiple agents acting together, and there might be 2 or 3 cycles. In the machine learning version of prompt optimization, the evaluation happens with labeled data. So the search for a better prompt is a machine learning problem using a metric like accuracy. So when you first come to the landing page of the Prompt Optimization Studio, Promptimizer, there are 4 tutorials to help you get started. The first one is medical diagnosis. The model should diagnose a patient based upon a description of the symptoms. AI detector. The model should determine whether text was generated by a human or a language model. Defect detection, determine if a part is defective based upon an image. And then search. So we're going to talk about the search use case in a little bit more detail. But before I do, I just want to point out that these data sources in these tutorials, they come from Kaggle or Hugging Face, and there are already prepared subsample data sets available for you here to download in this column as well. So first, let me describe a simple search paradigm. You start with a query, then using the query, you want to search millions of documents. The query is converted into some sort of index metadata-based search, such as keyword search, fuzzy keyword search, semantic, context-aware. There's many different kinds. So let's say you have millions of documents, you do a keyword search, and that's reduced to some smaller number of documents, hundreds or thousands. Then you apply a re-ranker, which could be an AI model, to re-rank the relevance of those documents to your search, and now you have a better order so that the best documents are at the top of that ranking. Search is used by a common prompt engineering technique known as RAG, Retrieval Augmented Generation. So in RAG, you search some corpus of documents, and then you try to get some highly relevant documents to help enhance the query. The problem is, say you ask a question like, what do wolves eat? That question might not be in those documents. The answer might be, but the question might not be. So there's this translation of your question into something to search for. So that could be done by adding an agent. So in this case, the search agent converts the question into something to search for. So for example, if the query is, what do wolves eat? The search agent might convert that question into 2 keyword searches, wolves and eat. It could also be wolf and wolves, and then that search is used for the fast index metadata-based search to cull the millions of documents down to a smaller set, and then the re-ranker is applied to get highly relevant documents that are then added to the prompt to enhance the prompt. So going back to Promptimizer, we're going to click on the search tutorial, but before we do that, we can download the prepared data file here, and then we just want to make note of the metric we're going to use, which is the LLM evaluator, which is our relevance agent. On this screen, we can edit the prompt of the relevance agent. So here you can see the prompt. I'm going to give you a question and some text. Rate the relevance of the text to figuring out the answer to the question. Give your relevance from the following list, and here we have relevance described in qualitative terms, which models are sometimes better at, and then later that's going to be converted to a quantitative number. Give your rationale and ranking in that order in JSON format, so that will make it easier for the information to be extracted later in the workflow to be used in the machine learning loop. So here's the label that we care about. It's called relevance, so that we need that to extract the relevance from the JSON. And here we pick the training data, which in this case is a corpus of files to search from. And then here's the question: what do wolves like to eat? So that's the query. That's our query that we're starting with. And we're going to use the relevance agent to find relevant documents to help us answer that query in a better way. And after one iteration, here's the best passage found so far. Wolves have been known to commit acts of surplus killing within the confines of human-made livestock shelters. Rare instances of surplus killing by wolves in Minnesota reported to leave up to 35 sheep killed and injured in flocks and losses of 50 to 200 birds and turkey flocks. So this is a raw score of 0.3, which is kind of lower, but this is just the first pass, so it's only looked at 25 or so examples. Once that passage is added to the prompt to improve the prompt, this is the answer. So I'm not going to read the whole thing. Wolves primarily prefer to eat meat as they are carnivorous predators. So keep in mind the language model could answer this question by itself probably. The idea is that this passage, which is from the mini Wikipedia data set, should enhance the answer. And you see here the first reference material provided does highlight a rare occurrence. Wolves can engage in surplus killing of livestock like sheep and birds. We can find among human-made shelters. So this is just the first iteration. And so after one more iteration, we see that the raw score of the best passage so far has gone up to 0.7. And if you read the snippet towards the end, you see the sentence, wolves usually feed on cattle at the kill site, with some parts being carried off. Wolves prefer to feed on the viscera and hind legs of domestic prey, though bones are often chewed and broken. So there's a little bit more information that directly answers the question of what do wolves eat. Thank you for watching. My name is Mark Shipman from Quante Carlo. For more information, please contact me at info@quantecarlo.com. Thanks.